Here we go for another episode of the 200 Challenge, where we are trying to identify weight savings off of my 964 Racer. We've already found 254 kilos, and this time around we're going to take a little bit of a break with the body and interior work and look at engines, which is something I really love. To my help, I have two of my favorite friends here. This is my current engine. I built this myself, got a GT3 crank, got all kind of goodies in it. It's a real beast. To my other help, I have my previous engine, which I didn't build myself. This is a 3.6, pretty much original, and we're gonna find some good ways of taking some weight off of these two guys. And we will start today's episode with the intake, which is, as you can see, super complicated. I don't know what they were thinking when they designed this. Actually, I do. They were pretty much constrained by the technology available at that time. I am not constrained by that. This is 2020, and I want to create the perfect mix of simplicity, modern, and classic. And that means I can do a lot to simplify this. Let's have a look. Before we get started, we're going to cover some of the basics of how an EFI engine works. That will help us to understand some of the other pieces that I'm going to cover today here. And I'm going to explain this from the viewpoint of the ECU. So first off, the ECU needs to know how much air is coming into the engine and essentially how much oxygen is available. The original 964 setup has one of these fantastic beasts. This is an AFM, an airflow meter. So what this one does, it has a little barn door in here. And as the air comes in, this one will actually open more and more and more depending on how much air that comes in. And then the ECU will know how much air is coming into the engine. This is the original 964 setup. A lot of people changed this to what is called a MAF, a mass airflow meter, which is just a different technology of sending a signal saying how much air is coming into the engine. Once the ECU now knows how much air is coming into the engine and it knows the RPM, it has something called a fuel map in here, and it will inject the amount of fuel that is programmed into the fuel map, and you get a result, right? And then you want to have a feedback loop, and this is our lambda probe. In the 964, you have something called the narrowband lambda, which tells you three things. It tells you if you're running lean, which means there's more oxygen available in the exhaust, meaning you haven't put really enough fuel in. And this is a really bad condition. It can lead to detonation, it can lead to knocking, and you will destroy your engine. So not good. It will also tell you if you are stoichiometric, which means you have the same amount of fuel as you have air, and you're essentially in a sweet spot there if you want to run economically. It will also tell you if you're running rich, which is what almost every race car does. And that means you have an abundance of fuel. Actually, all of it is not getting burnt, but that's how you get most of the power out, running just a little bit of rich. Let's also take the time to identify what the components of the intake are. We got the throttle body here where the wire comes in, and we got two throttle bodies actually on the early 964 ones here. The newer ones, they only have one big, one small. We have the idler valve here. This is prone to giving you some issues with your idle. And that one takes air from before the valve, and then it goes into the intake. And this is what the ECU uses to regulate the idle speed. On this side here, I have a throttle sensor here to say what the angle is. You have a little valve here. This one actuates what is called as a resonance flap, which sits under here, and I'll explain that a little bit later. You also have a little thing for emissions here. This is a little valve that opens over a certain RPM, and it sucks air through your carbon canister, through your fuel tank, and actually into the intake. And this has to do with emissions. So those are the basics for the intake. I'm going to start bringing some stuff out, and then we see how the new one's going to look. Okay, so I've been buying some stuff over the last period of time here. Let's try to figure out how we get this together, and we see how that looks. First up is a GT3 Plenum from a 996. This one has the benefit of having the exact same distance between the cylinder heads as a 964 has. Really cool. A lot of people have had great success with these. Looks really nice, looks really clean. We also have the communicating tube in between them, which is also where we're housing the resonance flap. So this is the device that keeps closed at low revs and then opens up as you get to the upper register. It gives you a little bit more torque in the bottom end. We're going to put this together, have a look at it. So that's easy enough putting that together. This, however, does not work at all. It is much wider than what the 964 engine is, and as I bought this, I thought this would just go bang together and it's easy. I got the GT3 intake, but it's not that easy. And now that I think about it, the GT3 engines, they have longer rods. The engine is wider as a whole, so this obviously doesn't work. So back to the drawing board. I have, in the most brutal and friendly manner I can, taken a few of these lamellas off and gone from that to that. And this seems to be what people do when they put these intakes in here. You could, of course, cut the aluminum, make it longer as well. I've seen some people do that. That is not very simple given how this geometry looks. This is how I did it. And there we go. We now have an intake that actually fits the width of the engine. So next step is, how do we control the air coming into the engine? If we look at what Singer does, they actually put individual throttle bodies under the intake. I've seen a lot of people done that as well. The old RSRs, they do that. I'm going to follow the path that the GT3s take, where you put an electronic throttle body here. So this is a servo-driven throttle body. It's super quick. It allows you to control the throttle with the help of a cable rather than a wire running all across the car. And it allows you to control the air during idle as well, which means all the stuff that is on the other intake, it just goes away and it's replaced by this. So first idea here was to just simply take the piece from the GT3. Obviously it doesn't fit in width, it needs to be shortened down, but there is another problem with it as well. And that is that it is very long. It is very long, it sticks out very far from the engine. So that's not going to work. So first step is a little bit of rapid prototyping, getting a piece in here. My first attempt at this was just taking a few steel pieces, cutting them up, welding them together, trying to wiggle it in there. And you know what? It's a lot of work and it's not going to look nice in the end. So I designed this instead and printed this. And this one has an integrated manifold air pressure sensor and a temp sensor in one unit. So that replaces the need for this or a math kit. Really cool. So I'm going to get this, I'm going to put it here with this here, and then we see how that looks. And that turned into this. So we now have an intake that essentially fits here, and we do have a throttle body on it. So we can control the air, we can measure the air with the pressure sensor and the temp sensor, and we are ready to go to the next step. And the issue we need to resolve now is that this one here is 57, 58, something like that, and these ones are 49. So this makes for a really poor fit here. If we try to put this together, it doesn't work at all, right? So I started off rapid prototyping again, made this. This now fits here. It's got a tapered design, so you get a little bit of this Venturi effect in this. So with these, we can actually try to put it on there. So I'm going to show you the iterations I made there. And the way I work when I try to iterate myself to a final design here before I make it out of aluminum or something like that, is I iterate myself there. And that means I put together sort of a careless design to start out with. I print it, I see how it fits, I adjust a little bit until I'm perfectly happy with the geometry. So this started out like this, and this one fits, but I completely forgot that this is an air-cooled engine and it needs to really keep tight here. So we put in this one. And this one fits really nicely. But the problem is the hole pattern is a little bit wrong. So I printed this, which has the right hole pattern, but the hole here is slightly off center, so that doesn't work. And in the end, I got to this one here, which fits perfectly. I'm really happy with the design. and I added a little bolt tour here for the fuel rail. And that means we have design-wise gone from this to this, which machined out of aluminum is going to weigh about the same as that one does, strangely enough. And we have a perfect fit here with also a component here that carries the same seal as you have in the 993. So we need to assemble this piece now. We're going to focus on this a little bit to see how we do up a fuel rail system and a good way of executing that. Together with the new intake runners, I need to do up a new fuel rail system. The one that comes on the 964 is somewhat complex. Fuel comes in here. It goes to this T-cross here in the middle, and it goes from there, distributes out to this side, and distributes out to this side here. Then it collects on both sides into the fuel pressure regulator, and then that goes out of the car engine over here. This is sort of a parallel system where you make sure that both rails have exactly the same pressure. You can do that in other means like that I'm going to do here with the serial rail system. You have to consider some of the dimensioning of this, of course, but you can really do it a lot simpler. So I'm going to take this off, put it over there, and we see how we simplify it. So this is now the lower intake, where fuel comes in here, goes out here, comes back here, collects back at the fuel regulator, and goes out. Looking at this one, the observant watcher will notice that my injectors are green, and that is because I've tuned my engine. And as you tune your engine, change ECU and so on, you will find that the original injectors on the 964, they're simply too small, no matter what kind of tuning you want to do. Now that we have this here, we're going to get into this, and we're going to see what we put together using the new parts we've prototyped and how it looks. Let us start with presenting the parts that I'm going to use. Of course, you've seen these, and you haven't seen this though. This is something that I did in cooperation with Nuke Performance here out of Gothenburg. It's a fuel rail system bespoke for the 964, bespoke for these. Really cool. I have a direct mount fuel regulator. This is actually a fuel regulator that mounts directly to the fuel rail. And of course I have some other little bits and pieces, injectors and so on. Let's put this together to a lower intake. You know what? It does fit, and this was, truth be told, the first time I assembled this. So we have the intake runners. I have put a little distance screw there to be able to mount it, and I fabricated a little bracket up here. So we got the injectors. This is going to be the left bank side, so the fuel is going to come in here, and the pressure regulator sits straight on the rail here. This does not fit like this originally. You can't buy a radium DMR, as this is called. You can't buy one of those so that it fits into this rail, so I had to modify this, to put it up in a lathe, change the thread and so on. Okay, time for first look. So we almost have a complete intake now. We start at this side, the injectors, the rail, ending up with the regulator, the direct mount regulator. The injector cables are going to come out here, so this will not look so nice. I need to figure something out here. The fuel comes in through this AN8 steel braided hose here, so that we get the same pressure in both sides. It's much bigger than what it probably needs to be. Comes out from this side. On this side you can see that the injector cables are actually coming upwards, and that is because I did a modification to the runners here. They look a little bit different, and that is so that now I can take the cables, take them up, take the cable this way here, and take it off this way. I think that will look a lot better. So this is cool, at least I think so. We've managed to really simplify this, get it looking much nicer, but I want to kind of go from cool to awesome, and this is my idea how we do that. We go to this. So from cast aluminum to carbon fiber, this is something that Jan Mertens from DRS Development helped me out with. This is a prototype. I don't know if anyone else actually has this, at least this exact geometry. I'm going to transplant the resonance valve from this one over here, This one is the same one as this one, but this is now printed in a material that can take at least 70 Celsius. I have also printed it in ABS here, which can take up to 100 Celsius. And I bought a roll of carbon fiber enforced PET, which can take up to 90. So I have quite a few alternatives for how I make this part. And I am going to make it out of my 3D printer. The lower intake part, that's going to be made out of aluminum so that it can withstand the heat. Let's put it together. Here we go, here's the final product. Light as a feather, of course, and clean as the other one. There is a little bit of work here to do, but this is just small bitsy pieces. I need to put a little vacuum hose from here to the pressure regulator, and I need to branch that off into a non-return valve, possibly a vacuum reservoir, and a solenoid to this one so that I can operate the resonance flap here. All in all, this is my complete final new intake. Let's put it on the engine. Final take, go. This is what we ended up with. I must say, I'm pretty happy with it. There are things left to be done, of course. Yes, there's always things left to be done. We need to fix up this gaping hole here, put a filter, either a flat filter or a filter that comes to the side. I haven't exactly decided yet, but I know I'm going to solve that some way. These guys here, I am either going to cast and machine those, I have some prices on that, or I'm just going to machine them out of billet. It depends a little bit if I think someone else wants to have this or not. But all in all, I think this is it. But before we quit, we can't forget about scoring time. Okay, let us start with establishing a baseline, which is the original intake, weighing in at 8.8 kilos, together with the lower intake and the fuel rails, which I'm gonna put in just like that. Now we're up to 12 kilos of intake runners, fuel rails, boots, whatnot. And we have the lower intake, which is these two guys here, together with the feeder line. This is 1.5 kilo, and I do need to add 1 kilo for the difference of these being in aluminum, as well as the boots that I'm missing here. So 2.5 kilos for the lower intake with fuel rails, full Monty, all included. And the runner-up to go on top of the lower intake is, of course, the GT3 cast aluminum piece, complete in its entirety, 5.8 kilos. And we have the last contender, weighing in at 3.2. I'm going to round that off to 3.5 because what we have that is missing here is the vacuum reservoir and a few vacuum lines. So let's make this 3.5 plus the lower intake of 2.5, meaning this is 6 kilos compared to the original being 12 kilos, which means 6 kilos just on an intake. Who would have known? Okay, so what did I learn today? Well, I learned that failing 3D prints means it takes forever to record an episode, because for every successful one of these, I have 3-4 unsuccessful ones, which means it really takes forever putting the whole story together. I also learned that there is 6 kilos of weight saving going from 1990 technology to what this is, which I would say this is modern technology. That is considering that you've already gotten rid of this guy. If you still have your AFM in the car, there's another 3 kilos there, which means, yeah, it's a significant saving. I still have some work left on this. I'm gonna cover that in a future episode. I really liked filming this. This is really something that I enjoy doing, this design piece. It's much dearer to my heart than the body panels and so on, but it's a big mix of fun things building a car. That's it for today. We're up to 260 kilos total. Subscribe to my channel if you like what you're seeing. See you next time.